recording now. So, question last time, the topic last time was on classes and things like that, how to organize your variables together into a struct or a class. Today we're going to be continuing our discussion of classes and talking about constructors and destructors because they are on your Zybooks on pointers that are due on Sunday. So, this will all be very useful stuff. Going to go over the bridges assignment. No. We got a lot to cover today. Maybe I will, but not before class. So, as far as the bridges assignment goes, given the number of people that were asking me for help starting it within the last 24 hours, it just reinforces something that I really want to drive home with you, which is to say you need to start homework assignments early. This isn't like, you know, your high school English teacher saying you need to start your essay now, you know, you got 4 weeks left, and everybody, you know, you wait till the last minute and you write your essay and it's fine. In English, you don't get stuck on your essay usually. You know, like, you don't just like get to a point where like your essay doesn't work, you know, because you just turn it in and it's got bad grammar and whatever, you get a B on it instead of an A, it doesn't matter. In computer science, you can get to a point where you don't know how to do something, right? Where like you're trying to read from a two-dimensional array and it's not working, or it's going out of bounds or something, and you don't know why. And that is why you have to give yourself time to fail. And it's something that a lot of high school students don't learn very well, is how to fail well. And you know, in computer science, I'd always try to make sure that my homeworks were done a day before the deadline. Because sometimes something horribly wrong would happen. My code would start seg faulting and my code would crash or not work right. And I needed that extra buffer so that I could see out all the things and try and figure out where it's going wrong and fix it. And if you try and, like, you know, wait till the office hours, you know, an hour before it's due, like, you're not going to get it done. Like, it's just, you know, you need to get stuck early so you get unstuck early and so you can have it done on time. It's just the strategies of life you've developed in high school don't work in CSI 40 unless you just don't write bugs or you cheat on Chegg or something. Then it goes very smoothly. But that's also not a good strategy for long-term success either. So, yeah. All right. So last time we talked about structs, and we want to make a variable of type person named x. So person is the type, the variable name is x. That's how you do it. The other 8 people guessed, I guess. I don't know. Yeah, it's just like making it named x. That's it. Given the struct and variable x above, how do we set x's height to be 198? So we use the dot operator. The dot operator controls the sub-variables within a variable. So x has 3 variables living together under one roof. It's got dot name, dot height, and dot bank account. Dot name is a string, dot height is an int, dot bank account is a double. And so x dot height is the height. And that's just a variable, and we can use it like any other variable. Okay? All these other things are just completely wrong. Suppose now that we have a vector of persons as described above, named vec. So we got a vec of persons. How do we set the bank account balance of the person at index 10 to be 0? So a vector dot at 10 gives you a person. And then you set the bank account on a person by saying dot bank account. So that's how you do it. That's a vector. Vectors just don't have bank accounts. The individual elements inside of a vector has a bank account. The vector itself does not have a bank account. So this is that. All right. So let's go on for today. Let's talk about constructors and destructors. So let's say that we're going to make a vector and this vector is going to be representing a x and a y location or something like that, right? So in physics simulations, we'll use like a 3D vector. You know, we'll have an x, a y, and a z. And the, you know, if you're going to have a position, your position in 3D space is some x location, some y location, some z location. But also you can use this for like velocities, so you can be traveling 5 units to the right in the x direction. Do you guys kind of get what I'm going for here? So you can have like a vector 2 named Bob. Bob.x is equal to 10. Bob.y is equal to 20. You guys understand? So what we have here is a variable named Bob. Bob is 2 integers living under one roof. 2 integers inside of a trench coat. It's just 2 variables together. Bob is 8 bytes big. And we can set Bob's x value and Bob's y value this way. And so if we want to move Bob to the right, we can say Bob x plus equals 5 or something. So Bob's x is 15 now. Okay. There's universal initialization syntax like this, which will set bob.x equal to 5, bob.y equal to 10. Like that. So that's a little shortcut there. But in general, what we're going to do when we work with classes and structs and things like that is we're going to make these things called constructors that initialize the variables in a class, and things called destructors that free up any memory that they have allocated. So let's say that we got here an integer pointer named history. So let's say that we are going to keep track of the last 10 spots that we went to in our vector here. It's going to record its last 10 spots. Well, we're going to need to do this, right? We could stack allocate it, but you know, if we made our history large, right now the size of the history is only 10, but what if it was bigger? Then we'll need to heap allocate it, right? Stack allocations are not great for arrays. Maybe a small array of size 10, sure, no problem. But we might at some point come in and do longer and longer histories where we're recording the path that the thing has taken, like if you're making snake or something like that. Okay. So we could do it down here like this. We can say bob.row. Sorry. Bob.row history is equal to new int vec2 : history size. We could do it like this, and then the same for the column history. And then every time we move Bob, like write down the old one or something, I don't know. For so let's do that, I guess. And then let's like move Bob around. Let's give him a velocity or something. So we'll do vector to velocity, and let's give him a velocity of 2 in the x direction and -1 in the y direction. Bob is moving 2 in the x direction and -1 in the y direction. Okay. What does : mean? It's called the scope resolution operator, And I did a little tricky thing here that I don't want to explain. Basically, I made a constant that is associated with the class vector2 rather than with a variable. So I don't say Bob.historySize because it's not a part of Bob. I actually don't want to waste memory holding history size over and over again for every variable of type vector2. So instead, vector2, the class itself, has the size of the arrays built into it. That's what the static there means. It's static means it is part of the class, not part of each variable of that class. So, waste. And you access it using : like this. So class name, : and then that'll give you 10. Okay, so why not make it global? Because it's part of the class, right? We're describing the class. The class itself keeps track of its size. All right, so it would work as a global. It'd be fine. A lot of people do it like this. Okay, so let's move Bob around based on the velocity, and then we'll record this into the history. Yeah, like Hazelton says, it's an organization of code thing. It doesn't it wouldn't it would work, right? Your code would work. The only question is does it belong as a global? Philosophically speaking, does it belong as a global? I would say no, because it's not a variable that needs to be passed to every function and so on and so forth. The only people that need to know about the size of the history are the people that are messing with the vector2 class, and it's there. It's part of the package. So, okay, so let's move Bob around. So Bob.x plus equals velocity.x. Bob.y plus equals velocity.y. So 10 times we're going to change Bob's x and y location, and before we do that, we will row substitute call s row dot. So Hazelton, do you use s? Like you use CW, right? CW to change the word to be float or something like that. You can also do 3s, and that'll delete the next 3 letters, and then you can type something. So it substitutes. So S by itself is kind of weird because it deletes 1 letter and then puts you into insert mode, which by itself is just kind of pointless. You might as well X and then type the thing. It's just a very odd thing. But W and B, yeah. So if you do like CW, then it deletes the whole word. But if you want to just like history size and change it to be like history location, I would go 4S and then location and then dot like that. So it substitutes a certain number of characters. Okay, DW to delete to next white space. Yeah, but if you want to see, here's the thing. Like if you do DW insert something, if you hit dot, then it doesn't do the substitution, right? And a lot of times when you do this, you want to change part of a word to another part of a word, and then it goes into the dot command. Just nice. Yeah, CW though, I never used CW before, and so I picked that up from your talk, which is the same thing as S, but you don't have to count letters. Just CW something. Okay. So before we move Bob, let's record Bob.row history square bracket I is equal to Bob.row. Bob's column history is equal to Bob.column. And then we update it. Okay. And then we're done, we'll just print out the history of Bob. So technically we just print it out as we go along, but I just want to demonstrate to you that we can like write down some history and print it out later. So cout Bob at time I was at parentheses Bob dot column, that's X, yeah, followed by Bob dot row slash N. Okay. Missing initializer for Bob row history, that's fair. It'll initialize to 0 though, so that's fine. And then we'll have a memory leak, I think, right? And there we go. But here it goes. So it works. Ooh, does it work? It doesn't work. What's going on here? Sorry. Call history square bracket I. Bob row history square bracket I. So what we've done with this code is we've created an array allocated on the heap that doesn't go away ever. Actually, we don't have any deletes in our code right now, so we're violating the rule of the Sith, right? Every new must have a delete. So we're not doing that right now. So we're leaking memory, and it's going to complain at us if we're doing that. But what we're doing is 10 times we're going to save into the row history the current row value, save into the column history the current column value, update the row and column, and then once we're all done, we go through the history and print it all out. You guys understand what's happening here? And so you can see that here's the last 10 spots that Bob with. You guys understand? Kind of. All right. What would you like to know about Portnoy? So we've got a class, and the class is allocating memory here. The range of both loops have the same range. Why wouldn't they just be inside the same for loop? I could. Instead of doing all this nonsense, I could have just printed out the value as we went along. But the point here was just to demonstrate that we could record history as we go along, and then at some point later on, come back in and view the history of Bob. We could have this be in a function or something. So we're making a struct of vectors or a vector of structs. Neither. We have no vectors anywhere within this code. We're making an array, a dynamic array. We're newing 10 ints off the heap. And so what's happening is we've got an array down here, 400 bytes. No, that's 100. 40 bytes. So when we do this, we are allocating 40 bytes off the heap, and we are saving the location of that into this variable here called row history. And then we're doing the same here, allocating another 40 bytes and saving that in a pointer called column history. And so row history and column history are up here on the stack somewhere, and they have a pointer to this chunk of memory down in heap. Okay. Now, why are we leaking memory? Why is it complaining at us that we are leaking memory? No delete. Yeah. So we could do this, Bob, there, delete, square bracket, Bob.row history, YYP, delete Bob.column history. If we did that, then no complaints anymore. We're good. But this is, it only matters if the code continues to run. But basically, this is kind of a terrible way of writing code. right? Where we've got to like new things, like stick it inside a Bob and hope that whenever Bob goes away, somebody remembers to delete it first. It's just not a good way of writing code. In C++, there is this philosophy called RAII, which is to say resource acquisition is initialization. Don't worry about it, we just call it RAI, which means let the class handle the allocation and deallocation. Okay. So we do this using two things. Technically three things, but we're going to go over two things today. Learning point number one is something called a constructor. A constructor is called when a variable is made. And class variables. Primitives don't do this. An object is made. Okay. The syntax is as follows. You write a function that has no return value with the name of the class as the function name. So it looks like this. Like that. Okay. And you can have it take no parameters, which would happen if you did this. Like if you said back to Steve, like that. Works just fine. It's going to call this function here. And what this function should do, what a constructor should do, is initialize all of your variables. Okay? So what should row and column be initialized to? Like, I'm just making a vector2 named Steve. What should our row and column be? It has to be something. I don't like it being uninitialized. So what should we set row and column to? What do you think? Okay, row and column equals 0. Sure. Okay. And then this code down here I want to allocate the memory inside of my constructor, like this. So the class is going to handle the allocation and deallocation of memory. So when Steve is made, secretly, behind the scenes, this is how a constructor works. When I type vector2 Steve, secretly behind the scenes, secretly calls Steve.vector2. So when you make a variable like Steve here, no parameters passed in or anything, you might notice that it's yelling at us for passing in parameters because our constructor doesn't take parameters yet. When you do that, then it calls this function secretly. And it will set Steve.row. Steve.row is going to be equal to 0. Steve.call is going to be equal to 0. So forth. Okay. That's why, if you ever wondered why when you do string s, why do I not need to initialize it? Why? Because it's got a constructor. Yeah, you can say row equals call equals 0. The assignment operator returns the value that was assigned. So when you say column equals 0, that's an expression, and it returns 0. And so it sets row equal to 0. Okay. You just put a function without parameters in the class. Yeah, we're going to be talking about class functions next time. For now, we're just going to be talking about constructors and destructors. Yeah. So destructor gets called when the variable is made. A destructor gets called when it's deleted. And you can have different constructors as well. So you can have a default constructor, which is what this is called, default constructor, like that. And we can have a vector that takes new row and new column. And this one gets called when you do vec2 Bob. You pass in two numbers. So if you make a variable of type vector2 named Bob and you pass in two variables to it, like down here, or velocity, whatever, then it will call this one instead. And it will pass in 5 for new row, and it'll pass in 10 for new call. You guys understand? So if we just make Steve here has no parameters being passed in, calls the default constructor. If we pass in 2, and exactly 2, it won't work with 3 or 9. If we pass in exactly 2 parameters here, then it's going to call this one instead. So in this case, our row history and column history should be pretty much the same. Oops. Y2Y, paste. But rather than setting row equal to 0 and column equal to 0, what should I set row to? What should I set column to? My row, Bob's row, it's not Bob.axis, it's Bob. Bob.row in this case. Correct. So row should be set to be new row, and column should be set to be new column. Okay. So what this is going to do, it's going to be called anytime you do something like this. If you say vector2 airplane, and the airplane is located at 100, 200 or something like that, this will set airplane dot row to be equal to 100 and airplane dot column equal to 200. We can also call it this way, biplane, because it's the old way of doing it. 100, 200, and this sets biplane dot row to be 100 and biplane dot column to be 200. There's no difference between these two versions. Modern C++, we use curly braces. We use curly braces to do universal initialization. Curly braces typically mean initialization these days, but the old way, the original way that it was done, was with smooth parentheses. Both ways work, both ways are equivalent. Usually. Some exceptions may apply. Okay. So, you guys see this? So Steve here, when we make Steve, it's going to call the default constructor, and airplane and biplane are both going to call the 2-parameter constructor, the one that has 2 parameters. You guys understand? Now, our code is technically, I don't think it's gonna memory leak. No, it's memory leaking. And 924. Oh, because we're not cleaning these guys up, right? These guys are all leaking memory. We are cleaning up Bob, and we're cleaning up velocity, or no, we're just cleaning up Bob actually. So Bob is freeing up its row history and column history, but we forgot to clean up after velocity. So we're leaking that memory, and all this memory is leaking too. We're just leaking all over the place. If you call vec2 biplane, again, you can only, constructors cannot be called directly. Constructors cannot be called directly. They only can only be called when the variable is made. So you can't reinitialize it. If you want to do that, it's fairly common for people to have an initialization function that initializes something. And then the constructor would just call the initialization function. That's pretty normal. If you want to like reset something back to its original state, that's usually a separate thing. And oftentimes the constructor will just call that to reset itself. So what we need to do, why are we leaking memory? We got what and we lack what. Why are we leaking memory? What rule did we violate here? No delete for the corresponding new. Exactly. Violated RAII. Exactly. So, I don't know why I pulled out a black metal guitar, but it seemed appropriate. So, we are allocating memory, but we are not deallocating memory. So we need the second half of Ray here, just to handle the deallocation as well. So this is really garbage, right? It's really garbage to like make Bob, you just make Bob. You don't even see a new anymore. You just make Bob, and then you're just kind of supposed to know that you have to like delete parts of it. This is what we have right now is garbage design. It is super, super dumb, horrible design. What we want really is this. We want a destructor, and this is our second learning point for today. Learning point number 2 is a destructor. Automatically called when the variable goes out of scope. Right? You remember that from last time. We got our stack, and the stack goes down to allocate room on the stack, and then when we return, the stack goes back up. It'll call the destructor on all of those elements, if they have one. Primitives don't. Integers just, they know snap, turn into dust, they're gone. But a destructor is like when Spider-Man is about to die. Hope you guys have seen Endgame. Spider-Man's about to die, and he's being killed by Thanos. And he gets to get off the last few words. Mr. Stark, I don't feel so well. That's the destructor. The destructor is the thing that gets called when you get snapped out of existence. Okay, I don't feel so good. Yeah, exactly. So the destructor, the syntax for a destructor is you write a function with no return value whose name is tilde and your class name. Looks like this. Vector 2 takes no parameters. Okay. So this isn't going to be very helpful, but it'll be funny. So each time one of those vec2s is going away, it says, I don't feel so good, Mr. Stark. And then we're still leaking memory because we didn't do what we're supposed to do. But it's funny, right? It's funny. It's good humor right there. Dark humor, dead Spider-Man or something. Okay. So every time Steve goes away, and airplane goes away, and biplane goes away, and Bob goes away, and velocity goes away, we got 5 different vector 2s. It is calling the destructor. And our destructor should be deleting these things we allocated, right? Instead, we're just printing out, we're being funny, so let's get rid of that. Let's do the delete for realsies now. So delete row history and delete column history. Okay, so now our class is correct. Each new has one delete corresponding to it. So you can either get newed this way in the default constructor, or you can new the memory this way in the 2-parameter constructor. Either way, these things are guaranteed to be newed, and when we go out of scope, it will always trigger the destructor on us, and the destructor will kill the memory on the heap. So we've got down here somewhere on the heap, we got the row history and the column history both allocated. When we go out of scope on the stack, like if we have a vector 2 on the stack up here somewhere, and the stack pointer goes up, it'll call the destructor on us, and the things that we have allocated down on the heap get freed automatically. It's beautiful. You no longer need to write news and deletes down in main. And in fact, if you have a new or delete down in main messing with row history and column history, it's probably going to be wrong. Okay. You run this, and down here, notice there wasn't any leak or anything like that. If we say delete bob.row history, so if we do try deleting it, now we're deleting it twice. Double free. Bad. And it tells you which line you screwed up on, right? So it was deallocated here in the destructor, vector2's destructor, on line 29 of file main2.cc. And we deleted it also on main2.cc, line 51. So we've deleted it twice. Okay, and it tells you both places. This is something called address sanitizer. You get address sanitizer turned on by that flag right there. It's super useful. Or if you use the compile shell script that I made for you, it turns that on by default. So it's really nice. And yeah, double frees are bad. Memory leaks are bad. If you delete something without allocating it, that's probably bad too. Might not cause a crash, actually. Like, what if we just forgot to allocate that memory? Then we're going to go out of bounds, right? Seg fault. We access memory address 0. The minefield of doom. Address points to the 0 page. Minkrell, you were looking for the name for the minefield of doom, right? It's the 0 page. There you go. That's the official name for it. The 0 page. I think minefield of doom sounds cooler though. It's 0 page. It's right there. So we're trying to read and write to the 0 page. So site faults kills us. Okay. So yeah. So address sanitizer is nice. It will detect your memory errors for you, and a lot of you were not using that on the Bridges Mountains assignment, presumably because you didn't know about it. So if you had compiled your code with this, then it would have told you where you were going out of bounds. So, minefield of doom is cooler. I do agree. Okay, so what can we do with this? What can we do with a vector 2? Well, we've got our constructor, we've got our destructor. Let me make sure we're not, yeah, let's get rid of this. So now, notice what happens. We just make Bob, and Bob, behind the scenes, is going to allocate memory. And when Bob goes out of scope here, at the end of main, when it goes out of scope, it automatically frees its memory. It's called RAI, R-A-I, R-A-I-I. You don't want to ever write code with news and deletes, really, if you can get away with it. No news is good news. Okay. MF Doom. Good reference. Good reference. Yeah, MF Doom named himself after the minefield of doom. That's a good one. Okay. Rest in peace. He died like a year ago. Okay. So what can we do with this? Well, I think it'd be kind of cool to make like a physics simulation, or like you could have a wall, and you could have like a racquetball, and the vector 2 could be like the position, and you have a velocity, and every frame the ball moves to the right based on the velocity, if the velocity is pointing to the right. I think that'd be kind of cool, right? Do you guys see how we could like use this to make like a physics simulation, or we could have lots of balls bouncing around? Yeah, yeah, Pong would be perfect for it. So why don't we go ahead and do that? So let's copy public. Okay, so there we go. So let's bounce a bowl of ramen up and down. You can see the alignment gets screwed up when you use Unicode. But I can add to the velocity, and I can use WASD also to mess with the position. So I'm hitting left a bunch, so you can see that it's fighting gravity as I push it to the left. Okay, so you can WASD around, and then I can add velocity if I want. I should fix that. Let's fix that. Pretty quick way of writing code, huh? So there's our vector 2, right? and then I just real fast typed in some non-blocking I/O code with a WASD controlling the position and up arrow and down arrow affecting the velocity. Okay. So we've got here a world map. This is basically the sample code for your RPG assignment, right? It's got a world map. You can get and set characters on it, which we're not using at all. Okay, print world. So this is where our bug is. So it's going to print out a little world. And then if we're on the player's location, we're going to see out a bowl of So what we want to do is probably, if we are not on the player's row, I'm going to do this. Unicode's really annoying, by the way. Unicode is super annoying. So for this, +1, and I call them -1 is better. So then we're going to see out nothing. So if I'm 1 to the right of the Unicode character, then it prints out nothing. So this does cause it to sort of eat the wall, but it's okay. So you notice now it's not doing the weird offset thing, because the Unicode character is technically multiple characters, and PuTTY doesn't necessarily render it properly. So there we go. It's got a bouncing bowl of ramen flying around. We can increase the speed, and yeah. Where do you get the ramen emoji string? It is Windows key dot. Pattern not found. Come on, Ben, you can do better than that. Oh, I'm in the wrong file. That's why. There we go. So yeah, you go into insert mode, Windows key dot, and then you can scroll through the different emoji and stuff like that. Do a poop emoji bouncing around, whatever. Ninja cat. There we go, Ninja cat. So Ninja cat's even more characters. It doesn't render properly, unfortunately. Okay. What can we have bouncing around? Poop emoji. Classic. So we'd have to make a movie based on emoji, huh? Have you guys been to was it Ichiban Ramen? Down on it's like on Fresno and Cedar? Fresno and First. I just went down there for the first time last week. It's pretty good. I liked it. Sean First, yeah. Yeah, it's got a bunch of anime drawings up on the wall. I was in there last week. It's pretty good. I was kind of sad that Masa's Ramen went out of business. Masa was this old Japanese dude who was, let's see, right here. S21. Yeah, Masa's Ramen was here, and it's no longer in business. I was very sad because I'd been practicing my Japanese on how to katame, koime, like how to order ramen, in Japanese and stuff like that. And he went out of business. So, a place called Kurotaka Ramen is taken over, and I've had Kurotaka Ramen before. They're pretty good. So, it's not a total loss. But apparently, Ichiban Ramen is he worked for Masa's or something. I don't know. I'm not sure. Order food in Japanese, yeah. Okay. They shop at your Costco. Oh, that's cool. Okay, so let's go through the code here. So here's the vector 2 we just wrote in class. Looks pretty similar, huh? And then we've got some static variables who are named a little differently because I just copied and pasted the 12 o'clock class over here. And then let's just go through this code so we can understand it. We've got a world map, and we're going to assume it's rectangular or things will break. So rows is how many, it's the world map is a vector of strings, right? It's a vector of chars essentially. And so the size of the world map is the number of strings in the world map. So it's the number of rows. And then if we get the size of row 0, that's the number of columns. And hopefully our code is all rectangular. If we ever do something like this, we're probably going to segfault. Or maybe not. I don't know. Don't listen to me. Okay. So don't listen to me. It won't work right. Trust me. So the that's the number of rows. That's the number of columns. We're at 10 frames a second. We start off with our position set to rows divided by 2 and columns divided by 2. So we're going to start off with our poop emoji in the middle of the world. And if you guys have a emoji you would prefer over that one, I'm more than willing to listen to you. What do you guys feel like? Have a deer emoji. Rocket ship. Ramen. Cheese. You see the cheese here? Sorry. Here, it's got cheese bouncing around, and it's cheese, so we should probably make it yellow, right? Yellow cheese bouncing around now. Okay. So that's holding our last position. That was in the previous code from the sample code to avoid flickering, because what my previous code was doing was saying if you didn't move, don't redraw the screen. But for this simulation, we're basically going to be moving every frame, so we could kind of just delete this. But I'm going to leave this in because this actually created a very nice, cool bug in the previous section. And so we'll talk about this on Friday when we talk about the rule of 3 and why this caused a bug, this last position there. Turning on non-blocking I/O, turning off the cursor, printing the world map, and then it will go into an infinite loop until we type Q to quit. I can use WASD to control the position of the cheese. I can use up and down and left and right to add and decrease the velocity of the cheese in either direction. And then we have a physics simulation now. So this is kind of what I wanted to show you here. So that is physics. That's a game physics engine. All right. So every frame, which isn't great, but for every frame, we are going to update the position of the cheese based on its velocity. So if there's a velocity of 1, then every frame it will move 1 to the right. Okay? So, you guys understand the relationship between position and velocity? If you guys taken mechanics, physics, velocity is change in position over time. It's making sense to you? It's not making sense, let me know. Still got almost 20 minutes left. I can just sit here and stare at you. Time would just be iterations. So this isn't great game design because when the frame rate goes up and down, my cheese will move faster or slower. So what I really should be doing here is normalizing based on how much time has gone past since the last frame. But I'm not doing it since I'm clamping the frame rate at 10. And a lot of video games do that. They just have a flat, this game runs at 30 frames a second, always, permanently, boom. And then they don't have to worry about delta time and things like that. Yeah, so this is per frame. So the velocity is velocity per frame, not per second, per frame. So a velocity of 1 means, if we have 10 frames a second, then a velocity of 1 means it's going to move 10 spots to the right per frame. Then what happens when we hit a wall? What happens if you throw a racquetball and the racquetball hits a wall? What happens? Anyone know? What happens to the ball when it hits a ball? Like you're in a racquetball court, which is like an enclosed cube, basically. You throw a racquetball, hits a wall. What happens? Bounce back, but go down due to gravity. Ooh, we could add gravity to this. We could add gravity to it. Also goes through the wall. Yeah, so without this code here, it would just go through the wall. So the first time I wrote this in the previous class, the ball flew to the right and went right through the wall and just kept going. Right? So what we have here is some bounds checking. And this is something that I want to reemphasize for the bridges mounted assignment, which is you need to do bounds checking. Every time you got an array or something, you need to make sure you're not going out of the bounds. A lot of students their code would crash if they were on the top row, the bottom row, the left, or the right, because they're accessing data out of the boundary. Every time you do a square bracket, you should have an immediate sensation of like dread and doubt and fear. Every time you have a square bracket, and it's not just like reading I or something like that. If you're reading from like I minus 5, there should be that immediate moment of like, is I minus 5 ever going to be negative? Because negative is out of bounds, guaranteed, right? You always, every time you're accessing something in a 2D array or a 1D array or any array, that you have to make sure that the thing you're pulling out is in the bounds. And what we're doing here is we're bounds checking based on the world map. So we're saying if our position ever goes off the top here, or if our position ever goes off the bottom, then what we do is we flip our velocity around. So our velocity will flip based on if we hit a top or bottom wall. Then our vertical velocity is mirrored. Okay. It should lose a little velocity, that's true. We should have a elastic coefficient or something like that. However, we're using integers, and so integers don't work very well if you multiply by 0.8 or something. It would just turn into 0. So we could do gravity though. I think that's a great idea from Mr. Herr. So why don't we say so what is gravity? Is gravity position, velocity, or acceleration? Does anyone know? It's acceleration, yeah. So acceleration is change in velocity. So the velocity dot rho plus equals 1. And I could probably make this a constant. Constant gravity equals 1 because I dislike magic numbers with passion. This is, now you understand what's happening here. Let's see what happens. I don't know what's going to happen. Let's find out what happens. So every frame, the velocity downwards gets higher and higher. Hey, check that out. All right. You see that? It's actually moving in a parabola. If I started a little bit lower, let's see here. Let's start it at 3 times rows divided by 4. We'll start a little lower so it doesn't get quite so much speed. Boop, boop. No. Wait. So it's accelerating, but then it reflects upwards. Interesting. So it picks up a lot of speed, then it goes up, and then it hits the top and it reflects back down and pulls. Interesting, yeah. Physics simulations are hard to do accurately. What do we want to do here? So the velocity. Because we don't have doubles. Like, doubles would make this really easy. We're doing integers. So I'm just going to leave it like that. Okay. So it keeps pulling downwards, but it's reflecting off the bottom and going, you know what, I'm just going to add, I'm going to make the world a little bigger. How about that? So YY 20p. And let's see how that works. There we go. Whoa. Bouncy. 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 Wow. I think the amount of kinetic energy in this world is increasing. I don't think that's accurate. First couple bounces were correct, but then it's actually picking up velocity because it's essentially falling. Interesting. Bouncing higher with each bounce. It looks cool though. We should probably, fine. Let's do elastic collisions, I guess. So anytime we bounce, we will. We'll lose 80%. We'll lose 20% of our momentum every time we bounce. What do you guys think? Kind of cool, huh? Gonna move it up a little bit. Not bad for like 20 minutes of effort, huh? Yeah. It's a little bouncy ball kind of thing. Because what's happening is that the gravity keeps pulling it down, and then it was reflecting back up, and then it keep pulling it down, you know. And so it's actually accumulating velocity. So doing a little bit of an elastic collision on that, causing it to bleed off its kinetic energy. Published a cheese game. Boing, 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 boing. Yeah, alright. So, bring it up higher, 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 higher. There we go. Not bad. Not bad. Alright, so let's, what was the, that's history, so we will do last command 2692. Is Hazelton still here? Hazelton, you know how to do this? Like, you can dig through your, you know how to dig through your history and type history, pipe it through grep, search for something, pipe it through tail to get your last 10 commands. Seen that before? So, yeah, so I couldn't remember the name of the thing I put up in public, so it's ramen bounce. So it's now cheese bounce. So, I don't want to do that one. I want to do 2657. Okay, so now it has been updated with gravity. If you guys want to copy this, if you want to look at it, if you want to admire it, it is now on here. I'm actually going to post both the 12 o'clock and the 2 o'clock lectures today because they're covering kind of the same topic, but kind of had different experiences. I'm actually going to post both of them for today. All right, so let's talk about mountain bridges. So if you guys go into the public mountain bridges, mountains 40 directory, you will see that I have a file in here called called sample solution. And so the sample solution code is a sample solution for how to solve it. So I noticed some of you were copying from it and didn't get it to work even still. But so this is kind of the heart of the assignment. So it just kind of hard codes in the Colorado file, which I don't think exists. Yeah, so this is kind of a complete implementation of the solution without all the function calls and things like that. So it starts off by reading in a file. It reads in the data into the doubly nested or a 2D vector. It then goes over each row, and for each row it is going to go from the left to the right. And so basically this is solving, I think, the it's solving the solution for every row. So it's not just doing one row going across, it's solving every row. And I think it's going to find which one has the shortest route from start to finish. Okay. So it's not exactly the same problem you're doing. So you can't just copy this. I saw some people trying to copy it, and they're wondering what to do with total changes and things like that. It's a different problem because they didn't want to just give you the answer. So this is grabbing the elevation at your current row and column, and this was the assignment, was seeing if you could get the current elevation at a given row, at a given column, out of an array. And you could have either done it using a 1D array that was a 2D to 1D coordinate map system. You'd either use square brackets and do the algebra and pull the elevation data for the current spot out using algebra, or you could refactor it to do a 2D vector like this. Either way works. And again, the problem that most students had was they just didn't start early enough on it. So this grabs our current elevation, and then it sets the cost of moving northeast to be integer max. Integer max is 2.1 billion and change, and this is how you bounds check. Anytime you do a square bracket or a dot at, and there's a minus in there or there's a plus in there, your immediate thought must be, what if I go out of bounds? And so if we're trying to see what the value is to the northeast, what if we're on the northmost row? That will go out of bounds if we try grabbing data from the row above us, right? So this is, you have to bounds check. You have to add an if statement. And this is something a lot of students didn't do. Their code would just crash. If they ever got near the edges, it would crash. And that's because they were accessing data outside of the vector or the array. So what we have to do is something like this, where you say if the row is if the row is 0, essentially, then we're not going to grab the northeast data. So if we're on row 0, we just don't grab data from the northeast. We say the northeast direction is like an infinite distance away, and so it just won't pick it. And then southeast, we do the same thing. So if we're on the bottom row, then it will say the southeast direction is an infinite distance away. Don't go there either. And we can always go to the east because we stop one column back from the edge. So we can always go east. And so we don't have that if statement on the east. And then if they do exist, if we're in the middle somewhere, then we will get the cost to the northeast, the cost to the east, the cost to the southeast. So SE is the difference in elevation from our elevation and the elevation over there. And then we just do a couple if statements. There's a better way of doing this too, but whatever. So if northeast is the least, then we move up a row and advance the column. If southeast is the best, we move down a column, or down a row rather, sorry. And we always move right a column. So all of these column pluses should probably be pulled out. This. I think I just wrote it that way so you can see 3 different ways of adding +1 to column. And if there's a tie, then I flip a coin. I think I default to going east first, and then if there's still a tie between northeast and southeast, I flip a coin. Okay. And then the new elevation is I grab the data for the new spot we're going to. I write down, this is for my own personal edification, it's not for your assignment. I write down the difference in elevation between my current one and whichever one I move to. And then after I've iterated across the entire map, I push that total change into a vector of total changes. And then when the, so basically I'm running shortest path kind of on every single row in the image. And then when I get to the end, I loop through that whole thing and I say, hey, which one is the smallest? And I say row 5 was the easiest route. If you have to traverse the Colorado map, which row should you start at? And so this is a different algorithm. It's a different assignment than what I gave you, but the heart of it is the same. Okay. Biggest problem you had was the San Joaquin map and the elevation values of -1. Yeah, and that's because there's a crashing bug in the bridges code. The bridges code crashes. Not your fault. Oftentimes not going to be your fault in the real world. And that's one of the things this assignment was trying to teach you. So sometimes code's going to crash, and it's not your fault. You need to figure out why, and you need to figure out how to fix it. So I put that in there intentionally. I left it in there intentionally. So you need to handle it. So the easiest way of handling it is it's the color. It's actually the code that is coming up with the color for the output pixel. It doesn't handle negative numbers. It doesn't handle negative elevations. They assume that the slowest elevation on a map will be 0, which is wrong. You can have negative elevations in real life. Assumptions are the deadliest thing in computer science. If you make a bad assumption, then your code will crash. If you make a bad assumption when you're writing code for an airplane, the airplane will crash and kill people. And that's happened before. If you look at like the 737 MAX, right? If you look at, there have been a number of crashes over the years due to faulty assumptions made in aircraft design. And so anytime you do something, you have to sit there and think like, wait, can I guarantee that elevation will always be positive? The answer is no. Are there places on Earth with a negative elevation? Yes, there are. You know, for like something like a person's height, a negative height is nonsensical. You can't have a height of -5, right? But for elevation can be negative, and they just didn't think of it. The sample maps they had were all up in the mountains, and so the thought that you could have a sea level map didn't occur to them. And I encountered this bug too. When I made my Korea map and my California map, my code crashed, and I went, huh? Why is my code crashing? And it took me a while to figure it out. And then I realized like that was a good exercise for my students, so I left it in there for you. Okay. Does address sanitizer work like the optimizer? Address sanitizer tells you when you go out of bounds. Tells you when you go out of bounds. And one thing that you probably want to do right now, because I'm going to, based on just looking at Canvas, it seems like most people didn't do the assignment. I'm going to extend the assignment for 2 days. So what you want to do is you want to go into the make file and add into CPP flags -f sanitize equals address. Just like that. Okay. And you can turn up the optimizer too if you want. Make clean, make clean, make. Do that compile time then. I told a student to use address sanitizer to stop their code from seg faulting. Probably won't. Address sanitizer should not cause their code to stop seg faulting. It's if they have undefined behavior, it could, but it shouldn't. How about that? How about that compile time? Woo! because it needs to be added to LD flags as well. This make file is way too complicated. Okay, fine. Here. Let's fix this. Is that book's not acting up anymore? I haven't heard any reports from other people on it. So I deleted the Zybooks assignment, I deleted the Canvas assignment, and then I remade them from scratch. So it should be fine. You might need to go back in and resubmit your stuff or whatever. But yeah. Okay. And there we go. So compiles fine. Alright. So what you want to do is this. Add that to your makefile. -f sanitize equals address, -f sanitize equals address, and then that will tell you when you go out of bounds. It'll tell you which line of code you go out of bounds on. It's nice. Okay. So I'm extending the assignment 2 more days. Good luck. Have fun. And I will see you guys on Friday.